What is going on, guys? Welcome back. In this video today we're going to learn how to parse and extract tables from PDF documents in Python. For this we're going to compare multiple approaches and packages. If you like this video, let me know by hitting a like button and subscribing, but now let us get right into it. Alright, so when it comes to document extraction, working with PDF documents is oftentimes quite challenging because the format is not optimized for being parsed, the format is not optimized for structure and readability, it's optimized for portability, as the name portable document format already says. So unlike HTML files, XML files, or JSON files, we don't have any predictable structure, any predictable tags or keywords in PDF documents. We have to work with whatever we get. Sometimes this is going to be images, sometimes it's going to be text, sometimes the tables are going to be delineated by lines, by drawn lines, sometimes it's just the spacing that tells you that this is a table. And what I want to do in this video today is I want to compare different approaches for extracting structured table data from PDF documents in Python. And for this I have prepared 3 different example PDFs. We have the DigitalOcean PDF. Here, for example, a table can look like this. We have some lines. We have some spacing here as well. We have another table down here. Maybe you could consider this also to be a table. Then we have Safari PDF, where we have a table like this. We also have a table like this down here. So basically, there are 2 table kinds. We have stream tables that look like this. So that would be delineated or separated by spacing, margins, paddings, and so on. And then we have tables like, for example, here, which are called lattice tables. These are tables separated by drawn lines. So you can see we have a structure here indicated by actual lines, not just by spacing. That would be a lattice table. The other one would be a stream table. And you can see also this document here is a scan, so I cannot even select anything here because that is not text. This is a scan. This is basically just an image. And this is quite challenging to work with. If I go into my terminal, I navigate to this directory, and I, for example, open one of these files up as a text or in a text editor, you can see we don't have anything like a table tag or anything like that. We don't have raw text here. We have some stuff that is made or that is optimized for looking the same at in every operating system, in every editor, not for being easily parsed. So we need to use parsers, we need to use packages to do that. So I want to get started right away with the first package, which is Camelot. We're going to install it by saying pip or pip3 install camelot-py. In square brackets, we're going to specify CV, and we're going to put all of that into quotation marks. And Camelot is a Python package made specifically for extracting table data from PDF documents. It's also compatible with pandas. So let us open up a new file, extract_camelot.py. And here I'm just going to say now import Camelot. And the extraction process is quite straightforward. We just have to say camelot.readPDF. Then we need to specify, of course, the PDF, safari.pdf, for example. Then we need to specify the pages. We can say pages is equal to all to just extract the tables from all pages if we have multiple pages. Then we're going to say flavor is equal to, and now we can either choose stream or lattice. Stream is for space separated tables or for padding, margin separated tables, and lattice is for line separated tables, so when we have clear delineations. And here I'm just going to go with lattice now, and we are going to do the same thing with stream in a second. And then I want to also say suppress stdout equals false. So I'm going to copy that, I'm going to paste that, and now I'm going to change this to stream as well. And let's just store this in 2 different variables. So I'm going to say lattice tables is equal to that, stream tables is equal to that, and then we can just say for table in lattice tables, we can say print lattice table and then print table. And we can do the same thing with stream tables, stream table, and that's it. So that is all you need to try to extract tables with Camelot. So just to see how well it performs, let's open up the Safari PDF document again. That is it. So we would expect it to extract this part and maybe this part here as well. So let's go and say Python 3 extract camelot.py. we can see, okay, I think, oh, sorry, I made one little mistake, because of course we don't want to just print the table object, we want to actually print the data frame based on that table object. So the data frame means we're taking the table and we're turning it into a pandas data frame, and that is what we actually want to display here. So what happens now is it finds one stream table, and that's actually the one down here. So maybe let me move my camera a bit. Actually, maybe let me move my camera to the bottom left for this video. And what we can see here is that it finds this particular table here, at least parts of it. So it finds invoice totals, it finds gross amount, it finds discount, subtotal, additional notes, tax. So it finds basically this table down here, which is fine. But it doesn't find this table up here. So if I go and say now, extract Camelot, and I change the PDF from Safari to digital-ocean, I do the same thing here. Let's see if something changes. So let's clear this. Let's run this again. Now I get a bit more. So now I get, let's open up that document as well. Now it finds a bunch of stuff that I'm probably not really interested in. It finds a stream table. This is the stuff up here. I guess this is what it finds. But all in all, it doesn't seem to find a table I'm most interested in, which is the summary table here. So that's the most obvious table to me as a human. This up here could be considered a table because of the spacing, a stream table, definitely. But I wouldn't consider this to be a very successful attempt. And then finally, the scan, I assume it's not going to be able to do anything here. So let's go and try to apply this to the scan-bio genx PDF. Let's do the same thing here, scan PDF like this. And my assumption is that I have a syntax error. Yeah, because I have PDF twice here. But now we get page 1 is image-based. Camelot only works on text-based pages. So it doesn't work. So it does work somewhat well for this one. It extracted this table down here. It did not work too well on this one, and it didn't work at all on this one. So Camelot, even though sometimes it can be a good choice, in this case now for our 3 examples, it performed okay at best. When it comes to this one, it didn't find this one either, but besides that, it didn't perform too well. So let us go to the next package, which is Tabula. Tabula is based on Java, and here now we're going to say pip or pip3 install tabula-py. Let's see if we can get better results using that. We're going to create the file extract_tabula.py. And here we're just going to say import tabula and import pandas as PD. We're going to work with pandas again. And all we have to do here is we have to say tables is equal to tabula.readPDF, quite similar to Camelot, but we're going to provide a couple of additional parameters here. So we're going to say, first of all, pages equals all again. That's the same. We also want to, first of all, before that, specify the Safari PDF path. And then we're going to say multiple tables equals true to allow for multiple tables at once. We're going to say lattice equals true. We're going to say stream equals true. So what you can see right away is that this doesn't work like Camelot, where we specify lattice or stream. We can set both lattice and stream to true in the same function. So it extracts both tables here. Then we're going to say guess equals false. And then we're going to say pandas_options is equal to header none. And you can change these settings. You can play around with that. There's more to play around with here. I'm just trying a default setting that's not too complicated. We want to extract lattice and stream tables. And now all we have to do is we have to say for I table in, or actually let's not do enumerate, just do for table in tables. We're going to say print table. So let's run this. And what I get here now is not very good. So I don't really get anything interesting here. That is, remember, that is the Safari PDF. So that is this document here. And it seems to have found charge detail. Where is that? Okay, it seems to find the header here. So it seems to find this charge detail, service period, subtotal, and so on, but it doesn't find anything else. Now, I'm not saying that this is the best performance it can get. There's probably some more stuff that we can tweak here to get at least some decent or some better results, but it doesn't seem to work that well out of the box, and I'm not sure if I can even make it to work better. So let's try a different file. Let's try the digital-ocean PDF. Here we don't get anything, so it doesn't extract anything at all. That's not good. And I assume the scan is going to be the same issue as before. Scan biogenics PDF is probably not going to be anything either. Okay, so Tabula, at least this code here, doesn't seem to work at all. So it doesn't seem to extract any of these tables properly. It seems to be able to extract the header here, even though I said header none, but yeah. So yeah, it doesn't work too well. The next package I want to take a look at is PDFPlumber. This is a package, as far as I understand it, that is well known for accuracy and customizability, or being able to adjust certain parameters. So we're going to try an approach here. I'm going to say pip or pip3 install PDFPlumber. In my case, again, already installed. I'm going to open up a file here, PDF, or actually extract _ PDFPlumber, py. And here we're going to say import PDFPlumber, and we're going to say tables is going to start as an empty list with PDFPlumber open. And now here we're going to put our files. So safari.pdf as f, and then we're going to say for page in f.pages, or maybe let's call this PDF. So let's do PDF.pages. So this is going to open up the PDF. This is going to iterate over the pages. And now on each page, I want to get the tables. Tables on page are going to be equal to page.extract table. Now, PDFPlumber, this is important, is not a package that is only focused on extracting tables. The previous two, Camelot and Tabula, were specifically made for extracting tables. This is why they just had a simple read PDF method, which extracted tables. Here we have different methods, and one of them is extract tables. And what we want to do now is we want to pass some settings here as a dictionary. Now, first of all, let's do that without. So let's see what happens with the default settings. And then we're going to say if tables on page, for table in tables on page. We're going to say if table, tables append table. Or actually, let's do this differently so we can turn this into a pandas data frame. So we're going to say also import pandas as PD. By the way, if you don't have pandas, of course, you need to install pandas. So pip or pip3 install pandas. But we're going to say now append here a dictionary, and we're going to say page is going to be the page number. So it's going to be just PDF dot pages index of the page plus 1. And then we're going to say data is equal to the table itself, just so we have this as a structured output. And then we're going to say here for table in tables, just print them. So just print pd.dataframe table, table, and then data, like this. And maybe above that, we want to also print something like page is table page. There you go. Okay, so it's going to print the page and the table. So let's go and run this. Now we do get something similar to Tabula. Now, interestingly, we get a table here with a lot of none values. So this doesn't look too professional, but it seems to be extracting something. Probably there's some data in here. And then we have, again, this header here, but nothing more. So let's go and try to add some parameters here. Let's add some more settings. What we want to do here in the dictionary is we want to say vertical _ strategy is text. Same is going to be done for the horizontal strategy. And then also I do have some issues with autocomplete here. Something is wrong with my setup. And then we're going to say intersection underscore X tolerance. So we're going to tolerate intersections. And we're going to pass here 10. And we're going to do the same thing here for Y. So intersection Y tolerance. Now, this should improve the results. Let's run this. And we get some more stuff. So maybe let's do this in full screen. Let's get out of this. Python 3, PDFPlumber. And now we get some more interesting stuff. So this seems to be, as of right now, the best result that we have gotten. So this is way better than Camelot, way better than Tabula. So if we compare this to the PDF document here, we have the, what is it? We have up here, this is the first table, it seems. Then we have some charge detail, service period. We actually get the information here. That's quite impressive. Or actually, do we? We get this here. But we don't really... No, actually we do. We do get the information here. So that's quite impressive already. Now we do have some formatting issues here. It's not exactly the same as before. But you can see it just basically extracts line by line here. It is decent. It's definitely better than what we had before. Let's see if it also works with the other documents. So I'm gonna go DigitalOcean PDF. And that is this one here. I mean, we're not displaying everything here, but it seems to be extracting too much. It extracts basically everything, and it somehow just extracts the text, but it still has some formatting issues. I would say definitely the best up until now. Definitely better than the other two. Let's try to see if it can also work with a scan. I don't believe that, but no. Okay, for the scan, it doesn't work at all. For these two, it extracts a lot, so it's definitely the best solution up until now. It's not perfect, I would say. There's some formatting issues, but it's definitely better. Now, the fourth approach that we're going to take a look at is a little bit different and a little bit more unique, but it can be the best solution depending on your use case, and that is to use LLMWhisperer. Now, LLMWhisperer and Unstract are sponsoring this video today. However, you can follow along and do everything we do here for free. You don't have to pay for anything. You can do exactly the same thing that I'm doing here in the video for free, and you can test it out. So in order to use LLMWhisperer, we just have to say pip or pip3 install LLMWhisperer-client. This is going to install the package, and we're going to need an API key. But as I said, you don't have to pay for anything. You just have to go to unstract.com/start for free. Then you can go to LLMWhisperer, log in. This is going to get you to the dashboard. And here, all you have to do is you have to go to API keys and copy your API key into a file or into your script directly if you want to. For security reasons here, I have copied it into a file called .env. But basically, then you can just go and say extract_LLMWhisperer.py, and then we can say import time, and then from unstract.LLMWhisperer import LLMWhisperer client v2. And then all we have to do is we have to say client is equal to LLMWhisperer client base URL. Now we need to target the API. So this is an API request that we're sending here. https://LLMWhisperer api.us-central.unstract.com/API/v2. That is the API endpoint. And in addition to that, we need to specify our API key. So we just need to say API_key is equal to, and now in your case, you can just copy paste the key if you want to. I'm going to load it from a .env file. So I have a .env file where I have API key is equal to, and then the string that I copied from my Unstract account. So just go to this here, copy the API key. And in my case, what I have to do now is I have to say from .env import load.env. You don't need to do that. As I said, you can just copy paste your key, but since I'm recording, I'm going to do it like this. Then I'm just going to say load.env. I'm also going to import OS, just so I can say here API key is equal to OS get environment and then API key. So you don't need OS, you don't need .env, you don't need load.env. You could just paste your API key here if you want to. That is now the client that we're going to use. And all we need to do now is a very simple thing. We need to say result is equal to client.whisper. And we just have to specify the file path. In my case here, safari.pdf. And then what we're going to get as a result of that is we're going to get an identifier, so a hash that is going to identify the task that we submitted. And once a task is processed, or once the PDF is processed, we're going to get the result. So we're going to say here, while true, status is equal to client whisper status, and then whisper hash is equal to result whisper hash. That is just a status, and I need to close this, of course. And then we're going to say if status is equal to processed, then we're going to say result X, let's call it, is equal to client whisper retrieve. And we're going to get the results, which is going to be based again on the whisper hash. So result whisper hash. And then we're going to break out of the loop. Otherwise, if this is not the case, we're going to just wait for 5 seconds so that we don't ask too often. And all we need to do then is extracted text is equal to result X extraction and result text. So let's run this, or actually we need to print also the result, otherwise we're not going to see anything. Let's run this, and then I'm going to explain why this is a more unique approach and why this can be the best approach from all the available options. So you can see we're sending this, we're waiting, and after some time we get the output. Now what you see here is not a table entity like in Camelot or in Tabula, for example, where we get table objects, where we can iterate over the tables. This is essentially the PDF document extracted all together. So this is the entirety of the PDF file extracted here. And what you notice is that the structure is preserved. So you can see we have the invoice date up here, we have the address up here, we have the information here, we have the table here, we have also the table at the bottom. All of this is preserved in terms of the layout. And that is the power of LLMWhisperer, because as the name already suggests, this is a first step to then feed this into a large language model. So large language models can extract information from structured text, so from something like this, but large language models oftentimes have a hard time extracting it from chaotic text. So if you just take something that doesn't extract the text properly, it's going to have difficulty working with it. But if you give it a perfect layout like here, this basically looks like the PDF, but in text form here in the command line. If you give it something like this, it's way easier to work with that. So I can actually show you a comparison between this and another Python package called PyPDF2, which is also for text extraction, but it doesn't have this layout preservation. So I can actually create another one, extract PyPDF2 .py. You don't need to do that if you don't want to. But basically what we can do here is we can say PyPDF2, and we can also extract the information here without calling an API, but you're going to see the difference in quality. So if I say open safari.pdf, for example, in reading bytes mode as file, what I can do then is I can say PDF reader. I can create an instance here is equal to PyPDF2 PDF reader, and I can open the file. I can say number of pages is equal to the length of the PDF reader, and then dot pages. Then I can just say for page number in range num pages. I can say the page is equal to the PDF reader pages, and then page number. Actually, probably I can also just iterate over the pages. But then we can say now page text is equal to page.extract text, like this. And then just text plus equals page text plus 2 line breaks. And then we can print the text. So that would be text extraction without LLMWhisperer. I can close this and I can run this now for the same document. And you're going to see this doesn't look very good. So that is the kind of stuff you get if you do it without the layout preservation. So even if all of the content would be included here, it is not the same structure. So first of all, for us humans, it's more readable, but also for large language models, that's much easier to process. So if I, for example, take the other one here, DigitalOcean PDF, let's see what this would look like in LLMWhisperer. I just have to say DigitalOcean PDF. And then let's see. There you go. This is again all of the content that we have here, summary, total usage charges, and so on. Everything's included here. And that is the perfect step for taking that and feeding that into a large language model to extract information out of it. So it's not exactly the same approach as the other packages, but when it comes to table extraction, that might actually be your best bet because you get all the information, you get all the structure, and you can take that and give it to an intelligent large language model to make decisions based on that. And this brings us now to the other tool, which I just briefly want to mention, which is the Unstract Cloud. And Unstract is open source. LLMWhisperer is not. So LLMWhisperer is their proprietary approach for extracting the structured information. But Unstract itself uses LLMWhisperer and is open source. So you can host it yourself, or you can use it here in the cloud. And basically what we can do here, just a quick example, test PDF, let's call it like this, PDF, whatever. Let's create a new project here in the prompt studio. What I can do here is I can define a document parser. So for example, I can say extract the taxes. And then I can say plus prompt. Then I can say extract the total amount. And then maybe I can say extract the taxes as a percentage of the total amount. So I can define here certain fields. I can also say I want to have this as a number. I want to have this as a text or whatever. And what I can do then is I can add a document. For example, here's Safari PDF. And that is going to load the PDF here. And what I can do now is I have GPT-4o connected. So I have set this up with my API key. I can just run all prompts. This is going to run through all the prompts here, given this PDF. And what's important is behind the scenes, this is actually using LLMWhisperer. So this is taking the document, parsing it the way I showed you in the Python script. So we're getting the structured text. And what you can see now is we get 0 taxes here. We get 199 as the total, which is true. And we have 0 as the percentage taxes. So let's try with a different document maybe. Let's go manage documents and let's go with DigitalOcean. By the way, one thing that I forgot to show you, this is important because that's the only approach that's actually able to do that. LLMWhisperer can also extract the information from the scanned documents. So if I go to extract LLMWhisperer and I use the scan that no package was able to handle, I can actually get results using LLMWhisperer here. So that's not a problem. It's going to be able to extract the whole structured content from the scan, which is just an image. We get all the information, we get the table here, everything works. And that's the only approach of the ones that we looked at today that is able to do that. And we can also do that here. So now I have here DigitalOcean loaded. Let's take a look at that. Let's see, we have here actually we don't have taxes, right? So let's maybe change this. Where is this tax? GST is probably tax. So let's keep that. It's going to be 18% and it's going to be 0.56. Let's run all of this. These prompts are going to go through the document and that is going to then give us these structured outputs. So we specify we want to have numbers. Here we have text. Doesn't really matter. This is probably just going to give us also the dollar. So in this case now, since it's text, it gives us more than what we asked for. So taxes gives us the identifier here, the percentage, and the value. Here we get the total amount, and here we get the taxes as a percentage. Now let's go to manage documents and index the whole thing. So indexed successfully. And now if I go to the raw view, you can see this is actually LLMWhisperer behind the scenes. It takes the document, parses it as text, and then we can run this through GPT-4o to extract information. So again, it's a different approach, but I think that's the most powerful approach when it comes to extracting table data from PDF documents, especially the combination LLMWhisperer and Unstract. So make sure you check them out in the description down below. It helps the channel. It's free. You can just try it out. You don't have to pay for anything. You don't have to submit a credit card or something. You can just play around with that. But this was the comparison for today. So that's it for today's video. I hope you enjoyed it and I hope you learned something. Don't forget to check out Unstract and LLMWhisperer in the description down below. They're sponsoring this video today. Again, you're helping out the channel if you also visit the sponsors. Besides that, let me know in the comment section down below if you know other packages, other approaches to extract tables from PDF documents. Maybe we can find other interesting approaches as well. And besides that, don't forget to hit the like button and subscribe to this channel to not miss a single future video for free. Other than that, thank you very much for watching. See you in the next video and bye.